Okay, our today's topic is LCR circuit. So we'll be basically finding out the impedance and the phase difference between current and voltage. Okay, so let us discuss LCR circuit once again. So in LCR circuit, we have one inductance, one capacitance, and one resistance. So there's inductance, capacitance, and resistance connected to a battery, connected to an AC voltage. Suppose that is V equal to V naught sine omega t. And suppose VRMS is the RMS value, of AC voltage. Okay. Now we have already derived this formula that VRMS will be equal to root of VR square plus VC minus VL whole square. Now we know that voltage across resistor will be I into R, that is IRMS. Voltage across inductor will be IRMS into XL, and voltage across capacitor will be equal to IRMS into XC. Now, if I'll put all the value in this formula, that is equation number 1, then what I'll get is, I'll get VRMS will be equal to IRMS, and in the bracket there will be R square plus XC minus XL whole square. And this thing is called as Z, that is impedance of an LCR circuit, and SI unit of Z is ohm. So this is basically impedance and SI unit is ohm. So VRMS is basically equal to IRMS into Z. Please remember this formula is very, very important both for your derivation and numerical purpose. Now let us again draw our triangle again. So this was basically VR and this was VC minus VL, and this was our net voltage, that is VRMS, and this was our angle phi. This was phi because phi is the angle between current and voltage, and current will be in this direction only. So we have already derived the formula that tan phi will be equal to VC minus VL by VR. Now putting the value of VC, VL and VR, what we'll get is XC minus XL upon R, because VC is IXC, VL is IXL, VR is IR. I and I will cancel out. Similarly, what will be the value of cos phi? So cos phi will be base is VR and hypo is VRMS. Similarly, if I put the value of VR, that will be IRMS into R, and VRMS is basically IRMS into Z. So this formula will be R by Z. And remember, cos phi is also called as power factor. Now also remember two very important things. If VC is greater than VL, then the circuit will be capacitive in nature. And if VL is greater than VC, then the circuit will be inductive in nature. And if VC is greater than VL, then the current will be ahead of voltage. And if VL is greater than VC, then the voltage will be ahead of current. Okay, so this is how you have to calculate phi. Please remember that to calculate phi, you have to use this formula. Cos phi is R by Z. Okay, now let us discuss one important topic, that is resonance. So what is basically resonance? So resonance is a condition. Resonance is a condition in LCR circuit when Z is minimum. So the value of impedance is minimum and current is maximum. So value of Z is basically root of R square plus XC minus XL whole square. So to minimize Z, Z will be minimum when. So to minimize Z, now you can't cancel R because in LCR circuit R will be there. So Z will be minimum when this term can be equal to 0 because R cannot be 0. So we can use this term. So Z will be minimum when XC minus XL is 0. So XC will be equal to XL, it means 1 by omega C will be equal to omega L. So if omega is 1 upon root LC. So if the value of the source frequency is 1 upon root LC, then Z will be minimum. Z will be minimum and current will be maximum. So for resonance, please remember there are two graphs for resonance. One is for impedance, that is one is for Z, and suppose this is angular frequency. So please remember that Z will be minimum when omega will be equal to 1 upon root LC. So Z will be minimum at this frequency. And at this frequency, value of Z will be equal to R because XL and XC will cancel out. Similarly, at resonance frequency, at resonant frequency, the value of current will be maximum. So if omega is 1 upon root LC, then at this frequency, the value of current will be maximum and the value of impedance will be minimum. So value of current will be maximum. And what will be the value of current at this point? So IRMS is basically VRMS by Z. So VRMS by R, because at resonance, Z will be equal to R. Please remember all this formula and all these graphs for resonance. But remember that at resonance, XC will be equal to XL, VC will be equal to VL, and cos phi is R by Z. So Z is equal to R at resonance. So cos phi will be 1 at resonance. Okay, so this is how you have to solve questions and derivations of LCR circuit and resonance.